Okay, question 4 has a stone thrown upwards and following a curved path, and you want to explain why the path has this shape, so the shape of a parabola. Well, if you fire an object at an angle, so let's say their angle theta here, and at initial speed u, then this velocity will have two components. It'll have a ux component, so that's the constant speed in the x direction. And then it would also have a uy component. So that would be the speed in the y direction. And it forms basically just a vector triangle. So I'm drawing, so that's u, that's uy, and then this would be ux. Uy does change because there's an acceleration due to gravity downwards, like this. So depending on which direction you define positive, so say this is positive direction, so gravity would be negative. So when you fire the object upwards, gravity's a deceleration. So this object slows down in the y direction until it stops. Then it turns, well, it kind of turns, it comes back down again. So it speeds up or accelerates as it comes back down again. So the motion in the x direction, so say ux in this direction, or its speed in the x direction, doesn't change. So let's say you took snapshots in time. In the x direction, it would be constant like this, so just equal distances traveled in the same time. So that'd be the x direction. But if you looked at the y direction, so it would start with an initial speed in the y direction, it would move a certain distance in the same kind of snapshot of time. But you'll find that the distance it covers is less and less because it's decelerating in the y direction until eventually it stops. So maybe, so it's decelerated, it stopped, maybe it stopped, I don't know, here, it stopped there. So it's got a motion in the y direction and then it's got a motion in the x direction. So if you combine these two things, so if I'll try and draw the lines in here, so this line here, and here. So these are the kind of snapshots in time for the x and y direction. So like that. Just like that. So the lines in the y direction get closer and closer together because it's decelerating. So it's slowing down in the y direction. Something like that. So let's say one snapshot in time would look like this. So the ball is here, wherever object is. So there. And then in the next snapshot of time, the ball is going to be here. And then in the next snapshot, it would be here. And you just kind of continue this. So you can see that the x motion is constant. These spaces in the x aren't changing, but the y is changing. It's getting closer and closer together. So this one will be here, and then eventually it reaches a maximum at this point. So it reaches a maximum here. So that's the top of the parabola just there. So it stopped in the y direction. And now it's going to accelerate back downwards. So if I continue this a little bit, so it's going to start falling down like this, and then another snapshot in time. It's now here. And then the next snapshot would be here. So that means that the ball would be at that point. And I've run out of space, but you can see it's still parabola. So it kind of goes like, if I try and connect this together, so it does kind of that shape. And it would just continue down. And that's why this is. So generally, what you'd say is the motion in the x direction is constant. There's no force acting on the object in the x direction. There's no air resistance. But in the y direction, there is a acceleration due to gravity, which is going to decelerate it on the way up, but then it will accelerate it on the way down. If you combine the two motions together, you get this parabola.